Go.
Hey, folks.
Do the live stream in 5, 4, 3.
Let's count us down.
1. And hello.
Hi, how are you? That was really dramatic. I like
Hey, yeah. Good morning, good afternoon, and good evening.
it. Yeah, great to be here.
Great to be here. Here to talk about indoor farming, costs, and HVAC. So, welcome to our audience. You may have been joining us previously. This is what, number 5? We've gone through about 4 or 5 of these conversations already.
That's right. Yep.
And we're here to shed some light on indoor farming, how to reach abundant crop harvests in indoor facilities. So I'm excited for today's event. Nate,
Yeah.
how are you feeling today?
Me too. HVAC is an incredibly important thing, and most folks overlook it or don't talk about it nearly when they're planning their facility, budgeting out for the kind of all of the capital expense of the build. And so, yeah, it's a really important thing to talk about. I'm excited to talk about it today.
Wonderful. Thank you guys for tuning in. Again, if this is your first time, my name is Jason, here with Nate Story, our CEO at Bright Agrotech. And if you've joined us before, welcome back. I do have a question for you today. Still haven't figured out a good prize yet, so
1 month of Upstart University for free.
there you go. Well, this question doesn't have a right answer. So if you would like to know, what is the cost of electricity where you are at? If you're on the Google search bar, go ahead and let us know. What are you paying for electricity in your region? And would like to get a sense of what folks are paying out there.
Yeah. It's one of the fundamentals that you really need to understand before you start doing any operational expense accounting. So before you start deciding, how much will it actually cost to run this facility, you need to know what the cost of electricity is. And it's actually probably good to say what's the lower or the higher commercial rates in your area specifically.
Okay. And they
as opposed to residential.
Right, because they divide residential from commercial.
Right.
So how do you qualify as a commercial electric rate?
Well, I mean, if you're using it for your business, then you're typically at a commercial rate. There's a lot of different, depending on where you're at and who your utilities are, there are different categories there.
Okay.
So big, massive users of electricity at the corporate rates get much lower rates than, say, if you're using it for a very small business in small amounts.
Okay, well then here's the question. If you folks are with us, without Googling, what do you think is the national average commercial electric rate? Okay, let us know if you can take a guess. I think I have a guess, but I might be wrong. What's your guess, Nate?
My guess would be 11 cents a kilowatt hour.
Okay, good guess. All right, so leading us out here, HVAC and cooling. Before we get into it, Nate, I want to give a little background to Bright Agrotech and kind of the values and the reasons that you're doing what you do. For folks who may be tuning in for the first time, why are you working in this industry? What motivates you?
Sure. So most of our work, the reason we're doing these types of things is really to empower small growers. That's really what we're about. And so whether it's designing equipment that allows people to farm places that they've never been able to farm before, or software that allows them to access markets that they've never been able to access before, or just information that allows people to design and build small farms, that's really what it's about. That's why we do what we do.
Good. So empowering small growers, medium-sized growers, giving people the tools and information they need.
That's right.
Good. And a little about myself, I'm a big fan of job creation. I like to see these projects take off. I like to see jobs in the community. And so I quote a statistic. A guy named Robert Schweitzer wrote a book about growing up on a dairy farm. And he says in 1900, over 42% of the U.S. population lived and worked on a farm, and it was a backbone of our economy, right? And by 1990, the number had shrunk to less than 2%.
That's right.
And so, in general, you see, mom and pop farms disappeared over the decades. Bigger farms took over with heavy machinery, much higher capital expenses, big financing, big ag industry, right?
That's right.
And so one of the reasons I'm passionate about this work is we're seeing these mom and pop businesses coming back to the neighborhood, creating jobs, giving people a chance to participate in agriculture.
Yeah, absolutely.
Right? So that's why I'm excited about this. And welcome if you're just tuning in. We're about 5 minutes in. I'm going to jump in just to the benefits of HVAC, and of indoor growing in general.
You bet.
So Nate, why should you consider HVAC?
So if you're growing indoors, you're producing a tremendous amount of heat. I don't care what kind of lighting you're using. If you're lighting your crops at the levels at which they need to be lit in order to actually grow productively and economically, you'll be producing a significant amount of heat. So that essentially means that you need to figure out how you're going to get rid of that heat. Because if you don't, you turn your entire growing environment into a giant oven. And so traditionally in greenhouses, we have the benefit of just being able to vent that heat a lot of the time. In other areas, we have to cool. But in growing environments, we definitely have to cool. Sometimes we can get away with using ventilation, but by and large, if we're doing CO2 enrichment, if we're really trying to control our environment within a certain temperature range, it requires some level of HVAC or heat removal.
Yeah. So, to be clear, we are talking about fully indoor facilities powered 100% by LED lighting in this situation. But you were recently in a webinar talking about cooling the greenhouse, right?
Right.
And those don't require HVAC per se. They're much more about there's some swamp cooler type techniques people are using, fans, and so on.
Well, and that's that's one thing to think about is we do typically talk about it in the context of LEDs. However, traditionally people have used a lot of HID lighting. They've used greenhouses to supply light, using sunlight. There are costs associated with cooling no matter what.
Yeah.
However, the reality is the more heat you're producing, the more heat you got to get rid of, the higher the cost of HVAC.
Yeah.
And so in the classic LED versus HID debate, the cost of HVAC is one of the hidden costs that is very seldomly brought up. And the reality is that the cost of your HVAC doubles, oftentimes almost doubles, if you are going from LED to traditional HID lighting.
Interesting. Okay. So I have a short list here. The benefits of cooling your facility, growing indoors. Again, you can grow crops in any climate. You can grow year-round. You can provide the optimal climate for your crops. Also helps to control pests, right? When you have good climate control. Can you help us understand that a little bit?
Yeah, so climate control is important for a lot of different reasons. A lot of people assume that we're talking about optimal conditions for plant growth. Plants will grow at a certain temperature better than at another temperature. You've got your daytime temperatures, your nighttime temperatures, but it also plays into pest life cycles. So if we're talking about fungal or bacterial pathogens, how fast those things spread. When we're talking about heat, we're also oftentimes talking about relative humidity, and then we're talking about condensation points. Then we're talking about dripping, which contributes to pest and disease spread. We're talking about all of these different factors that are so closely tied together that it's really important to understand that this is a matrix of different variables.
Right.
And ultimately, maintaining good temperatures allows us to control relative humidity much better. It allows us to control pest life cycles. It allows us to control rates of photosynthesis. It allows us to control a lot of things that we can't control in the field.
Right.
And the important thing to come back to on all of this is that our ability to control those things is the reason we came indoors in the first place.
Yeah. Yep. So I'm imagining, it's pretty hot out right now. I'm imagining one of these facilities, kept around 72 degrees, maybe 75, good airflow. Sounds like a nice place to work.
Yeah, well,
Right?
compared to a lot of the greenhouses I've worked in or field environments, absolutely. It can be
Yeah.
a much better place to work. And for that matter, a much more constant, steady place to grow.
Right. Good. Well, so it's a nice place to work. That might be the number one reason to consider HVAC. But you can also maximize your crop yields, maximize the quality of the crop, and ultimately we're talking about profit, right?
Right.
Good. So those are some of the benefits of having a good HVAC system. But it doesn't come free, right? So let's talk a little bit about the costs and understand and unpack some of this for folks who are interested in the HVAC for their system.
Yeah, so HVAC is super specific to each growing situation. And a lot of people say, oh, that's a cop-out, but it's really not. Sizing an HVAC system depends on the crop that you're growing. So what are the temperature ranges you're trying to hit, both your dark and your light, your time and your nighttime temperatures? What's the variation that you want to have there? Where are you located? So what are your hottest summer temperatures? What are your coldest winter temperatures? What is the R value of the insulation of your building walls, ceiling, floor? All of these things play into doing these calculations and finding out how much you actually need in terms of cooling for a facility. And then, of course, the crop that you're growing, what type of crop it is, impacts transpiration rates, which contributes directly to the humidity of the growing environment, or relative humidity. And understanding that is what's most important to sizing a dehumidification system if you plan on dehumidifying.
Good. So I have, you're saying it's very specific to each situation. Now, we tried to come up with some ballpark figures or estimates that folks can use, but again, it's difficult, right?
That's right.
There are so many variables.
Depending on where you're at. I mean, and remember, too, that a lot of this is the cost of the installation labor. So if like Silicon Valley or something like that, then your labor costs are much, much higher than if you're in Alabama,
right,
or if you're someplace else with much lower labor cost.
Good. So here's a baseline number that we have. Estimates for HVAC can run you $10 to $20 per square foot just to purchase the equipment. So for example, we talked about an 1,800 square foot facility in our previous session. You're looking at $27,000 in equipment to get that installed or to purchase the equipment for that system, not including installation and labor.
Right.
Right. So my home, your home might be about 1,800 square feet. Just to put that in perspective. So $27,000 system, not including all the ductwork, all the upgrades to the electrical you might need, and this is a pretty smallish system, right?
Right.
So we're seeing fairly significant costs. Right here we have an example. A grower has about 5,000 square feet, and he estimates he has spent $250,000 over the last 5 years, including labor, including all of his nuts and bolts. $250,000 for an HVAC system.
Right.
Seems fairly significant.
It is significant, and it adds up. And with a lot of these things, because they're oftentimes customized to these growing situations, people using different equipment with very different kind of heat production. Basically, their operation is unique enough that a lot of this is ongoing too. So you have kind of the initial install thing, and then you have to kind of tweak stuff over time.
Right. So that's a good point. I'm glad you brought it up. We're not just talking about the initial cost of the system, but also down the road, operational costs, maybe how long does the equipment last?
Yeah.
How reliable is it? Do you have backup or redundancy? these are all costs you have to consider. So there you go, folks. Those are some numbers, but I here is that it is highly specific, and you'll want to be aware of all the variables that go into your HVAC system.
That's right. Think through them really carefully. They're going to cost you money.
Good. So how should we get started when we're thinking about a system? Maybe it's the first time you've put in a system, or your first time growing. How do you recommend we get started?
So the easiest place is to just start with heat, because everything that you're using in that environment will have basically, if you're looking at lights, it will tell you how many BTUs of heat each light is producing. So you can go through and add all of those up. You can calculate the efficiency of the wattage of the different appliances, pumps, those types of things that you're using. You just basically want to understand how much heat is going to be being created in your growing environment. So that's step number one. The second one is to get a good handle on the amount of moisture that's going to be in your growing environment. Because these are the two things that traditionally HVAC systems primarily take care of, is heat and moisture. And so then the idea is, what are kind of the peak loads there? So if you're looking at HVAC, you're doing holistic calculations. You're not just taking the heat from the growing environment. You're saying, on the hottest day of the summer,
right,
when I'm growing, how much heat is going to be basically coming from outside the building to the inside of the building, because it's 120 degrees in Phoenix or whatever it is.
Yeah.
And I'm going to be producing X amount of heat within the building. Doing all of those calculations to understand what your total heat load is in the worst possible scenario is really important part of that.
Well, you brought up an interesting point off the camera a little while ago. If you have if you're in Phoenix, for example, and you're dealing with 100-degree temperatures, you might choose to shut down the operation during the hottest part of the year.
That's kind of the last part of this. So it's how much heat, how much moisture, when is it necessary? So what are your peak loads? What are the times where you need to be most concerned about this? Like, what is the maximum operational capacity of the HVAC system that you need to install? And then the last part is, where are you willing to compromise? And this is a question that isn't asked very often, but we work through this with almost all of our customers, especially when we start hitting our heads against the wall of what they have a budget for or what they don't have a budget for, what the market can bear, what the market won't bear. And when you begin to really kind of bang your head against that problem, you start to ask things like, well, how important is it to you to sell over the course of the summer? I think there's an example that we talk about later here for a northern project that we did, where basically the conclusion was, you know what, we grow for as long as we can. In the middle of the summer, production from all of the summer producers is just incredible. So is it super important that we maintain capacity through the summer? Could we shut down half the system? Could we turn the whole thing off in the middle of the summer when our heating demand is so high? Let just the organic market take it over, and then start it up a few months later and hit the market as soon as the market starts to cool off again. So
well, and that's interesting. We know that the price of vegetables is higher during the winter when most growers are taking their vacations. Right. And that's a kind of a trade-off you're seeing with some of these indoor facilities versus conventional field production.
Right. And that's, again, that in very few cases does that make sense. But it's something that we have to talk about. And it's something that you should keep in mind, because what you're going here is not simple. It's for the economically optimal model. And so long as we're always shooting for the economically optimal model, that kind of informs all of these different decisions we have to make.
Right. And just kind of to give folks a heads up, what are some of the approaches people are taking? How many choices do I have when I'm choosing, what kind of system? Is it just conventional HVAC, or are you going to have other options?
No, there are a few other options out there. We tend towards water cooled systems. They're a little bit more CapEx intensive, but the operational expense is typically a lot lower in the long term, and they can be applied to a lot of different areas very effectively. On the 30th, we'll actually be unveiling something that we've been working on for quite some time that mitigates or eliminates the cost of HVAC for a lot of different growers in different environments.
Good. I was gonna ask if you were able to mention that, but
Yeah.
That's the 30th?
Tune in on the 30th. We're going to show something off that we've been working on for a while that I think people can get really excited about.
Fantastic. So we is working on a solution to handle these heating loads, help bring both capital expenses down and operational expenses.
That's right.
Okay. So we've got some audience responses here. We have Kyle in Lubbock, Texas. Thanks for joining us, Kyle. Says he's paying 9.7 cents per kilowatt hour. That's a good price. I think.
9.7. Yeah, that's great.
I think that should be commercial, so that sounds pretty good. Emilio in Vancouver. Thanks for joining us, Emilio. Paying 3.6 cents per kilowatt hour.
Ooh, I love that cost. That's a good price right there.
Yeah. Brittany in Red Lodge, Montana. Thanks for joining us, Brittany. 6.8 cents per kilowatt hour. That's amazing.
It's awesome.
Yeah. And also a David. Thanks for joining us, David. Paying 6.8 cents for commercial near Seattle. That's interesting. So saying that Phoenix, Arizona is about 10.22 cents per kilowatt hour. And finally, joining us from Oslo, Norway, saying his energy is certified renewable, and it's coming in at 7 cents.
That's amazing. Yeah, those are great prices. There are very few operations where there's demand for local produce, and electrical prices are below, say, 12 or 13 cents a kilowatt hour where it doesn't work. And if your electrical costs are even lower, it's insane. We are doing a study for an operation in Dubai, and they're paying 2 cents a kilowatt hour.
Wow.
And that's when your primary cost is basically 1/5 of what we typically deal with. It's like printing money. It's like printing money.
Interesting. Exciting things happening here. I like the renewables. I like just to see these prices. So again, if you want to guess, win a free month to Upstart University, our educational resources for indoor growers. And what is the national average for commercial electricity in the United States? Shoot us your best guess, and we have a prize to give away this time. All right? All right. So we'll come back to that in a minute. And Nate, you mentioned some of the things you need to keep in mind when you're approaching an indoor growing project, specifically with HVAC. Can we just go through real quick again and make sure people understand? These are the questions that your consulting team will probably ask you if you want to take on a project like this.
Right. So the first one is, what are you growing? So what crop is it? And that's important because crops grow optimally within a certain temperature range. But then we also kind of compromise there and say, what are the primary pests for this crop? And what is a suboptimal range for those guys? So where can we find a place where our crop is growing as great as possible while minimizing its susceptibility to disease, to pests, to pathogens, to the other problems that can arise? The second one is, what type of a facility are you growing in? So, is it greenhouse, indoor, hybrid? Is it, just a steel building with minimal insulation? Do you have a lot of insulation? What exactly is that? What's the R value of that? When we're doing these big holistic calculations, right, what are the environmental effects on heating and cooling loads? Those are questions we have to ask.
Yeah.
The third one is, where is your facility located? So where you're at, your highest summertime temperature, your lowest wintertime temperature, all of these things are, something that you need to know, that we need to know in order to figure out what your actual heating and cooling loads look like.
Right.
Because your environment has an effect, has a significant effect. Especially if you're up in the Arctic Circle or something, and I'm 60 degrees below zero temperatures.
I would love to come into one of these facilities in January in northern, the Arctic Circle, and it's 75 degrees, right?
Yeah.
Now do these lights actually eliminate the need for heating?
Yeah, so almost any indoor growing environment, almost all of the ones that we have looked at, researched, done the numbers on, the lights are almost the sole heating source.
Okay.
So, and there are other ways that you can use, say, like waste heat from the lights to heat during the dark hours. So if you are not staggering your lighting, and you do have cooling costs or heating costs during the dark hours, you can, of course, hold on to some of that heat and use it. But yeah, I mean, lights will heat almost any growing facility.
That's kind of a nice side effect of having all these lights in your facility.
Yeah,
especially
it's electrical heat.
Cold climates, right? That's fantastic.
And they produce a lot of heat.
Good.
A lot of heat.
So let's say we go through this process, with your consulting team, or you may be working with another team out there. How do you get to the numbers that you need for your HVAC? Kind of walk us through the basic process to this project design.
Yeah, so just to start with, the lights are almost always going to be the primary heat source in the growing environment. So count the number of lights, count the BTU rating per light, and that's kind of your baseline starting number for the amount of heat you're going to be producing in any given environment. Then go through, count the number of pumps, count any kind of electrical device, count all of these different things that are producing heat or adding it to the environment. Figure out what the general efficiency is. I mean, most motors and that kind of thing, say they're 20% efficient. You know that 80% of the electricity going into that unit or device will be just lost as heat.
Okay.
So if it's a 10-watt device, then you have 8 watts of heat, which is about 3.4 BTUs per hour per watt. And so you're looking at 28 BTUs of heat for that little motor, right?
Kind of a napkin calculation there, but you're saying a unit is burning electricity, but not all of that is coming out as heat. Some of it is going into...
Yeah, I mean, so like with all of these different things, the efficiency rating is basically how well is this device translating electrical energy into, for a light versus heat, right? So you've got, say for a 1,000-watt HPS light, it may be 20% efficient. So it's emitting 200 watts as light and 800 watts as heat.
Okay, so I think this is important, right? Because even with advancements in LED technology, we haven't reached 100% efficiency.
No way. We're still a ways off. So even with LEDs, a lot of people have this misconception that LEDs do not produce heat. The reality is, especially if you're driving the kind of intensities that you need in your growing environment, you will be generating still a lot of heat. So let's say the most LEDs are operating at, say, twice the efficiency of an HID light, right? Which is a pretty fairly true. If people are telling you something different, then it's probably not entirely trustworthy information. But let's say an HID, you've got an 1,000-watt HPS light that's functioning at 80% or 20% efficiency, so 20% of that electricity is emitted as light. An LED might be 40% efficiency. Right? So 40% of the electricity flowing into a 1,000-watt LED fixture is coming out as light. But you're still producing, 600 watts of heat versus 800 watts of heat.
So it's definitely an improvement over previous technologies, but you're still dealing with unwanted kind of waste heat.
That's right.
Right. So that's important. Thanks for walking me through that. I appreciate it. And so calculate your efficiency for your units and come up with a number. You're looking for tons of cooling, right?
That's right.
Okay.
So because lighting, we'll just focus on lighting because lighting is the primary heat contributor in these environments. So to start there, we look at the number of lights we have, the BTUs that are created per light. We multiply that up, and that tells us how many BTUs we need to remove. That gives us the starting number for the HVAC system. So the HVAC system, I think you looked up tons of cooling beforehand, but it's like 288,000 BTUs per ton, right? And so then we translate that out into the total number of tons of HVAC required to remove all of that waste heat.
Yeah.
And that's kind of our starting number. And then you talk with an engineer, and they're going to add a percentage of error there, 10% or something, just to make sure that they're sizing everything right.
So yeah, for folks who may not know what a ton of cooling is, kind of what we're talking about here is it's a unit of measurement that these engineers are using to calculate how much cooling you need. It came around in the industry when they had to when all the refrigeration was done with giant blocks of ice, right? So they would have to calculate how many BTUs does it take to create 1 ton of ice. And that's the original calculation. A ton of cooling, about 288,000 BTUs
of removal.
of removal. Well, because it's a phase change. They're changing the heat through a chiller or condenser of some sort into ice, and it takes 288,000 BTUs to create a ton of ice. So in case you're wondering, folks, what a ton of cooling is, that should have been our bonus question, Nate. And translates to about 3.5 kilowatts, which I don't understand, but I'm not an electrical engineer.
Yeah, so we can translate pretty easily from BTUs to watts, right?
Okay.
And especially, BTUs are describing this heat that's being generated, and 1 BTU is what does it take to raise I think it's 1 gallon of water by 1 degree, right? That's a BTU. So when we're talking about a heating system, we're talking about removing heat. So it's just the flow of heat. We're measuring that in BTUs, whether it's flowing from one place to another, or in this instance, being pumped or moved.
Good.
With this equipment.
So Nate, that's kind of a slightly technical discussion, but I want to help put it together for folks real quick. We have an example that we can talk about, a case study that you worked on up in Alaska, a northern climate, and looks like we may have some questions coming in. So I'll just go ahead and move us right into the analysis here. And you do recommend speaking with an engineer, right?
Yeah, definitely. I mean, especially if you guys are doing larger systems, you should have an architect, an engineer. You should have folks that really know their stuff consulting with you on this. It will save you time in the long run, especially if you're talking a fairly intensive, traditional HVAC system.
Okay. Good. So question, we'll take questions, you guys, if you want to send those in. We have a question from Raphael asking, do we need redundancy when we're designing our HVAC?
Redundancy is always good. Even better than that is basically building over capacity and then breaking it down in a way that where if one part of the system goes out, you do have like redundant units to back it up. Redundancy is always good, and engineers love redundancy. However, the difference is that engineers don't always design for optimal, economic optimal kind of situation, right? So they're designing for the physically optimal, and the grower having some of this knowledge, being able to give input on the design, allows the grower to say, "Hey, let's optimize this." So let's optimize this a little differently, right? So instead of 2 100-ton HVAC units, one is a backup, one is a primary. Why not? Let's break this down into 6 20-ton units, and then if one of our 20-ton units goes out for some reason, we can replace it. Now the capex is going to be higher on that, on a per ton basis. However, the overall cost will come down. So when we're talking about redundancy, it is very good, but you want to make sure that you know enough that you can interact with the engineers in a way that makes sure that you're getting the economically optimal redundancy.
Okay. Thanks for that, Nate. And the example that we're going to talk about here, this is a 7,500 square foot facility for indoor growing. You worked on this project, and can you kind of tell us a little bit about their options and how they approached the HVAC for their facility?
Yeah, so again, every facility is different, and for this particular case study, we were dealing with a farm where there's very cold winter temperatures, and the summer temperatures are not excessively hot.
Mm-hmm.
And when we started looking at the HVAC, because we were using very intensive lighting, it was very aggressive growing. The number here is about 53 tons. When I did my calculations with everything else, it was about 60 tons of cooling.
Mm-hmm.
Ultimately, that was very, very pricey, very expensive.
I think we heard it was $75,000 just for the equipment,
right,
to take on 53 tons of cooling.
My initial estimate is that it would have been around $120,000 worth of cooling installed to take care of that, which that's a big budget item.
Yeah.
So the goal there, what we did was we just did an economic analysis. We compared installing an HVAC and this intensive HVAC system to aggressive ventilation.
Mm-hmm.
Ventilation in their area is actually really pretty darn effective at cooling.
Yeah.
You do sacrifice efficacy on your CO2 generation. So enriching the environment with CO2, you're blowing a lot of that out. But when you kind of look at all of the different costs of that, the cost of natural gas, basically it justified basically using ventilation instead of HVAC. And I guess the one other point on there that I would point out is this is a great example of asking the question, where are you willing to compromise?
Yeah.
Because what this did is it optimized for all of that winter production, right? It optimized for winter production over summer production. And of course, in very far northern environments, winter is when all of your pricing goes up, when demand is high, and then you have competition in the summer. So,
interesting. So what you're saying is they actually opted not to install this $120,000 HVAC system, instead choosing a kind of air exchange with the outside air.
That's right.
Right. Just fans.
So yeah, and that just basically entails looking at your hottest summertime temperatures, figuring out what the actual what the exchange rate is to remove all of the BTUs being generated by the equipment in the growing environment, and then figuring out what your air exchange rate is.
Right.
And once you know what your air exchange rate is, you just install the necessary fans and equipment to make sure you can do that.
Which sounds like a great solution, but probably wouldn't work in some place like El Paso or
it will not work in El Paso or Phoenix, someplace like that, right? There you are looking at fairly intensive HVAC.
So the takeaway, I think, is, where are you located, what type of system are you looking at, do the numbers, do the analysis, talk to a mechanical engineer. And one of the benefits of the mechanical engineer is they can actually help you model the costs and the energy use. So they have very sophisticated software systems, right? They can look at your peak load, look at average daily load, and so those operational costs down the road. And we talked before the session today. It's a big deal trying to choose the right system, even if it's a little bit more money up front, to really understand down the road how those operational costs are going to come in.
Yep.
Right.
You live and die on your operational expenses. CapEx, you know what it is. You know what it looks like as you amortize it out. That's predictable. Capital expense, your ongoing operational expenses, that's where the unpredictability comes in. And that's where operations really live or die.
Okay. So take the time, do the analysis, run some energy modeling with a mechanical engineer. Try to be fully informed about the options that you have for your cooling needs, and give us a call. We do work with these systems fairly regularly. You have a consulting team. So yeah, folks, if you want answers for more specific situations, we're here. Give us a call. So that's pretty much the whole talk here. I do want to give a call out for the June 30th event. Get a sneak peek. Nate's solutions for indoor lighting that do promise to bring down both capital costs and operational costs. I really want you guys to know that this solution that Nate's working on has been very interesting to see. And I'm excited to see how you roll that out, kind of what that solution looks like for indoor growers.
Yeah.
Okay. All right. Audience questions, you guys. Thanks for tuning in. National average is coming in at $10.45 per kilowatt hour. I think we had someone guessing 10 to 11 cents. That was Kelly Fong. I hope I pronounced that right. Kelly, thanks for your answer. You are the winner of this week's bonus question.
And she's already an unlimited USU student. So
Yeah.
maybe we'll just randomly pick someone else.
Okay. So we've covered a couple audience questions, and that's it for today, unless we get one more coming in. Hold the press. We have another audience question.
That first comment there, basically, let's see. Kelly said, "I'm so glad you're doing this video. I've had a heck of a time explaining to my clients that LED lights give off heat. They seem to believe they don't. The reality there is that they give off a lot less heat than HID lights, right? Because we can usually get the same growing effect out about half as much wattage, because on a light emitted per watt basis, they're twice as efficient as HID lights. So say a 500 watt LED can replace a 1,000 watt HID light if it's a good quality LED light, which means that we're producing, a lot less heat overall, just because we're using a lot less wattage in our growing environment, but it's still a significant amount of heat. So you can usually cut your heat by around half by transitioning from HID to LED, which is a pretty significant cost when you're looking at HVAC costs. But they still produce a lot of heat.
Yeah.
And if you're figuring you're just going to throw LEDs into your growing environment and you're going to be fine, you're going to cook a lot of plants.
Mm-hmm.
So that's when talking about HVAC is really talking about reducing indirect costs, or costs that are kind of often overlooked, right?
Good.
It's not always a direct, obvious type thing.
So Nate, I'm excited to see the technology you've been working on. If you guys want a sneak peek of the technology, you can go to brightagrotech.com/innovation. Get an early exclusive look at what these lights look like. This is only available to folks who are watching the video. Nobody else is seeing these lights at this point. And then on June 30th, it sounds like you do have a launch event coming up. You're going to kind of pull back the curtain on some of the technology you've been working on.
Yeah. We're going to go into detail then for Kelly as well on on water cooling, and basically what water-cooled systems can do for indoor growers.
So that's the bonus. If you stuck around this long, please head over to brightagrotech.com/innovation, and you guys can get a look at the technology. I think we'll sign off with that, Nate.
Great.
Thanks for your time. I really appreciate it.
Yeah, my pleasure.